Okay, so now we will be going to the demo part. What I have done is like I have used Google Cloud, and in Google Cloud, I'm going to use this Vertex AI Playground platform. And I have already saved my prompts to uh, cut the time. I didn't want to write the prompts now during the live. But anyway, so we'll look at all of those prompts and see what each prompt is trying to do. So in Google Cloud, in Vertex AI, if you go to Studio, you get something like this where you can choose, you can give the prompt, you can give the context. Like let us say you can upload some PDF files or give a link to a particular data, and then you can ask the questions. Like you can also have something like a system prompt, which I'll show you what it is. So basically, initially there was only one prompt, but then recently what we have is like you have a system prompt and then you have a user prompt. System prompt is more at a higher level, and user prompt is at the task level. Okay, and the end user is going to solve some task. All so you have a two different categories. I'll show you both how the system prompt and user prompt is coming into picture. I have saved all my prompts here in this view all stage. The order might be different, but we will what we'll do is we'll try to uh, take one at a time and then go from there. So first we'll go with domain specific prompting. Uh, so here, if you notice the system instructions, I have informed the LM that it is a domain expert with deep knowledge in supply chain, logistics, multi-modal transportation, and global trade operations. Always use precise terminology, industry standard framework, and context-aware reasoning. When explaining the concept, adapt the depth based on user's question, but maintain technical accuracy. If the user provides incomplete information, ask clarifying questions before answering. Avoid generic definitions. Always ground your response in real operational scenarios, constraints, and best practices from the logistic domain. Respond to user in 5 bullet points. Now, let us say I remove this 5 bullets for now. Uh, okay. And this is the system prompt where a data scientist or you or a developer has given. We can also add user, the user prompt here as well, and then you can ask the user information to be passed. Okay, so now the user information is coming. You're an expert in supply chain analyst, specialized in multi-modal logistics. Explain how transshipment uh, delays affect last mile delivery performance. Okay, that's the question. Now let us see what the answer is. Wait, I think I did a wrong one. Let me edit this and then send. Now it is thinking based on this instructions that it is provided, and then it will look into the task and it will come back with the answer. So just hang on with me for a couple of moments, and then we can see the response. By the way, the model that we are using here is Gemini 3.1 Pro Preview. If you drill down this particular part, you will get to know what the model is and all. You can also see, say for example, if you can also see the temperature, what is the top P, what is the output token limit, and all of that. Probably this is for the next session. I can tell you what temperature is, what is the output token limit, all of that. But for now, just make sure that there is a LLM model that is being called, and there is set of instructions that we have asked the LLM to follow. I think it is almost done. So it has thought for 47 seconds. Now it is coming back with the answer. Now notice how the answer is pretty big, and it is pretty time taking, right? Because I did not specify like what should be the limit of the output. Now what the LLM is trying to do is it is trying to get all the information that we have given in the prompt, and based on that instructions, it is trying to decode this task, and it is coming back with the answer. No, you see the answer it's already big. Now I don't want the LLM to respond in this big paragraphs. So what I'll do is I'll stop it here and I'll say limit the response in max 5 bullet points. Okay. Now let us send this one more time. Now the assumption is the LLM should respect this particular instruction given to it, or the constraint that is given to it, and the response should be in such a way that all the information that it has gathered, it will put it in 5 bullets and it'll give it. See, 1, 2, 3, 4, and 5. And the response, you see, it has come back, it is quicker than the last time. The last time it was crossing more than 1 minute. So now it is just responded back in 7 seconds. So this is domain specific prompting, wherein you say a particular domain to LLM, and LLM will look into that particular domain based on the data it was trained, and it will come back with the answer. You can also provide some context. Now, let us say if you are talking about this transshipment, you can also talk about some information around transshipment, what you think is considered as a delay. So all that can be given. Maybe if you are giving some examples, then it will go for that few short examples. Okay. So now let us go to the next part. I'll just continue. The next prompt is the zero shot prompt. Now, zero shot prompt, as I mentioned, that I'm not going to give uh, any examples to the LLM, and you're expecting the LLM to resolve the task and come back with the answer. So look at the system instructions that we have given. You are a helpful and concise AI assistant. When the user asks a question, answer it directly without requesting examples or prior context. Do not assume any domain unless the user specifies it. Rely on the general reasoning and your existing knowledge to produce the answer. Okay. And now classify the sentiment of this review. The delivery was late, but support team resolved it quickly. Okay, so this is a prompt from the user, classify the sentiment, and this is the user input. The delivery was late, but support team resolved it quickly. So the sentiment of this review is mixed. It contains negative aspect, late delivery, and positive aspect, quick resolution by the support team. Now let us say I'll just send the user input now. I am not happy with how the logistics team has handled my shipment. Okay, I did not give the prompt again. I just gave the user input now. Now the model is going to look at it, and then it is come back, and it is going to come back with the answer. See, the sentiment of the statement is negative. If you can notice, I did not ask the model to classify the statement of this review. It knows that the user is trying to uh, classify the sentiment, and then it is when the user input was given, it has directly uh, classified it, and it came back with the answer. We now go to the few short prompt, wherein we can see the system instructions. Again, it is pretty generic, like what we have seen in the other prompts, like you are an AI assistant that learns from examples provided. When the user gives sample input output pairs, infer the pattern and apply it consistently to new output inputs. Your responses must be strictly follow the structure, tone, labeling style shown in the example. If the user's input does not match the examples, adapt it to the closest pattern without inventions of new labels. So what you're saying is that the model can expect a couple of examples given, and based on the examples, the user's input should be classified into one of those categories. Uh, we also discussed about golden samples, right? You can think of something like this. Like, let us say you have like thousands of samples, imagine, and all these thousand samples are stored in a vector store. Now, user has asked some question. So what you'll do is like based on the user's input, you will gather closely matched samples from those vector store, and maybe a top 10 or top 7 or maybe top 5 categories from the vector store are pulled, and that itself is passed to LLM along with the user's input. Now, what will LLM do? It will look at the golden examples, it will look at the user's input, and it will come back with the answer. So whatever you're seeing here, the three examples can be dynamic. You can replace what should go in sample one, or what should go in sample two, and what should go in sample three based on the the similarity of the user's input. Okay. For now, what we're doing is we are simply hard coding the context. We're giving the samples here in the prompt, and we are asking the LLM to classify what it has, whether the priority falls as high, low, or medium. So let us give it to the LLM. We'll give a couple of seconds to the LLM to respond, and LLM responds saying the medium priority is medium. Now, let us say if I uh, say now what are the in shipment arrives within 24 hours? Okay. I want my shipment to get delivered in max 36 hours. Now let's see what the LLM will respond with. So again, it is saying priority as high. It could not justify what 36 hours is because the other two samples does not contain anything around this 36 hours. Okay, so not every time the few shot examples is gonna also remain accurate. You have to make sure that the samples that you provide to the LLM cover all the patterns that are present in the business context. Because this particular statement of 36 hours was not covered in the samples provided, it thought like, it will go and sit in the 24-hour category. Okay, that's for the few short example. Now let's go to the next. After a few short example, we then go to chain of thought. As I mentioned, chain of thought is something you uh, where you ask the LLM to decide what should be the process flow. Okay, so here the system instructions. Your AI assistant that explains your reasoning step by step before giving the final answer. Break down the complex problem into smaller logical steps. You're asking the LLM to break it down, but you're not saying what should go for step one, what should go for step two. Show your intermediate thinking clearly using numbered and bullet steps. Ensure each step follows logically from the previous one and leads to a correct final answer. This is a system prompt. Now the user is sending the information. Rahul has 12 apples. He buys 7 more apples and gives 5 to his friend. How many apples does he have now? Please think step by step. What I'll do is we'll send this. Now, see how LLM breaks this task into a smaller task and then responds back. Because we have given in the system prompt that it has to come up with the reasoning. So the reasoning is this. Here is a high level summary of the reasoning. First, I factored in Apple's Rahul bought to his starting amount. So what it is doing is Rahul initially had 12 apples. He bought 7 more. So Rahul has 19 apples put together. Next, I subtracted the apples he gave to his friend. Okay. So he gave 5. So 19 minus 5, he is left out with 14. That's how it is dividing the task into smaller tasks and achieving the solution. After chain of thoughts, we go to the next one. What would be the next one? I think it is step-by-step decomposition. Correct. Yeah. So the next prompt is step-by-step decomposition. This is where uh, we define what should go as step one, what should go as step two. Now let us see what is a system instruction. You are a senior logistic planner and problem solving assistant. For any complex task, first decompose the problem into clear ordered steps before attempting a solution. Explicitly separate problem understanding, assumptions, decomposition into subtask, solution plan, final answer. Do not skip decomposition even if the task seems straightforward. When relevant, highlight trade-offs and alternate at each step. So in the previous problem of chain of thoughts, you did not say like what should the LLM do? Okay, you just mentioned it has to break it into smaller tasks and get to the solution. But here you're saying the first step is to understand the problem. Second is to gather the assumptions. Third is to decompose the subtask and so on. So you're specifying what should LLM do in step one, what it should do in step two, and so on. Okay, now let us go to the user prompt. We are facing a recurring delays in India to Middle East export lane. Current situation origin is Hyderabad, inland, cargo moves by road, and so on. So decompose this problem step by step before proposing solutions. Your task clarify the problem and list down what is unknown, state traceable assumptions where the data is missing, break the overall problem into subproblems, example documentation, inland movement, port, and so on. For each subproblem, outline possible root causes and data you would want to check. Only after that, propose a structured improvement plan with short-term and long-term actions. So all this is part of the prompt, and this is the user input. We are facing recurrent delays in our India to Middle East export lane. Now, let us send this to LLM and see what the response is like. So it came back with an answer. So here is the structured decomposition. So it is trying to tell what is the problem understanding. The core issue is like we are experiencing systematic delays and customer dissatisfaction in inland to ocean export lane, Hyderabad to Mumbai, and from Mumbai to Dubai, due to cascade of operational and informational failures. So what it is trying to do is like based on all the system instructions that were passed, it was trying to decode that problem statement into each of the steps. So first step is problem understanding. Second step is the assumptions. Next is decomposition of subtask. Fourth is subproblem analysis, like root cause, data to check, and alternatives. Like that is what we mentioned in the solution plan. And then it comes with the final answer. Okay, so this is a step-by-step decomposition. So just keep in mind, it is very similar to chain of thoughts, only with the difference that the user decides what the LLM should do in each of the step. Or you can think of it like a data scientist decides like what it should do in each step. Now, after step-by-step decomposition, now let us go to the next part, which is deliberate prompting. Was it deliberate prompting? 1 minute. Yeah, the next one is deliberate prompting. So here it is also like a workflow. Let us see what it is. You are a senior logistic strategist. For any problem, generate multiple distinct solution options. Each option must reflect a different strategy or trade-off. After gathering the options, evaluate them by using clear criteria such as cost, speed, risk, and operational feasibility. Finally, select the best option and justify your choice. Do not skip the evaluation step. So, as I mentioned earlier, in the deliberate prompting, you're asking the LLM to come up with more than one solution to the given problem, and you're also saying what should be the criteria on choosing the best solution. Like, in this case, we are saying like cost, speed, risk, and operational feasibility. So you're also defining the criteria. So based on those solutions that LLM came up with, it will choose the best one on these criteria, and it'll give the answer to user. In the user prompt, let us see what it is there. We need to reduce the average delivery time for our Hyderabad to Bengaluru e-commerce shipments. Okay. Current SLA is 48 hours. Target SLA is 24 hours. What are the constraints? Budget increases allowed up to 12%. Like it should not increase the present cost by 12%. Current mode of transport is road transport via line haul trucks. Daily shipment volume is 3,000 packages, and so on. You have set of constraints. So now you're asking the LLM to do some things. Okay, generate three different strategies to achieve within 24-hour SLA. Each strategy must be distinct. Like you don't want an overlap between two of the strategies. Then LLM, you're asking to evaluate which strategy is better in terms of cost, speed, scalability, and risk, and finally choose the best answer. Okay, so this is a deliberate prompting wherein you are making the LLM to think like a brainstorming session, come up with more than one solution, and choose the best solution based on the given criteria. So let us send this and see what the response is. In the meanwhile, I'll check what is the next topic. So we are there at deliberate prompting. Next is React prompting. So this prompting, it can be improved. Like let us say you think that the LLM is not responding uh, in a fashion that you want the LLM to respond with. So you can play around with the system instructions and user instructions and see how the LLM responds. You have to keep doing that unless or until you reach that point where you think that LLM is now generating precise answers that is expected from it. Okay, so this cycle we have to keep continuing to do it. Okay, now let's see what the answer is. It took about 45 seconds. So it has come up with more than one strategy. If you look at it, see strategy one, it says high frequency rolling cutoffs via LCVs. And strategy two is origin, fine sort, destination, hub, bypass. And strategies three is express passenger train integration. Of course, it is more on that business specific, logistic related. So probably a business person can identify each of these strategies and compare whether the LLM is going in the right direction or not. If not, probably you can speak to the business user and then modify the prompt in such a way that these constraints are more refined to give a profitable solution. Okay. Now let us go to the next part. Yeah, see, after selecting the three strategies, it has evaluated and final selection and justification. Okay. The next part, as I mentioned, is a React prompting. Now, React, as I said, is where you have an external tool call or a function call. So let's see how that is made. I'll just delete the old response. Okay, but this is what we have. So what I was mentioning in React was wherever you want the LLM to get the information from an outside source, maybe outside API or web tester or another RAG, all that can be done in React prompt. So look at carefully what we have mentioned here. You are an AI agent, uses React reasoning plus acting framework for every query. Think step by step using explicit thought statements. When an external action is needed, use action followed by the action name. After the action, use observation to incorporate the result. Observation is nothing but you're catching the response from that particular function call or API call. That response you're putting it in the context. Okay. And then you continue alternating thought, action, observation until you find the answer. You can keep doing it. You can make use of all the tool calls that are available and arrive at the solution and with final solution. Okay. This is what it is. Do not skip or hide reasoning steps. Now you see what are the function calls. Like this is a function, get port status. This can be dynamic. Okay, here I have kept it in the model settings, but You can think of it like, this information can be bought from outside. Instead of like, this can be a function and you pass some port name to it. And based on the port name, you get the response. If it is Mundra, you get this response. If it is Navasheva, you get this response. And if it is Chennai, you get this response. Okay, it's a simple function call. Similarly, then you have the route cost based on the origin and destination. What is the cost that is involved? Hyderabad to Chennai, Hyderabad to Mumbai. Okay. And then we have weather. Chennai, what is the current weather? Heavy rain, floods, port slowdown, and then Mumbai, clear weather, normal operations. Dubai, sandstorm, air delays, crane shutdown. Of course, I think they recently had a big sandstorm, but yeah. So this is what the tool call us. And now we are going to ask the user to send the information. Now, users is going to use those tools, and you're asking the LLM to do some task. A shipment needs to move from Hyderabad to Chennai urgently. Decide the best mode of transport using React loop. So it is going to make use of all these loops that is present, and try to solve the problem of sending a shipment from Hyderabad to Chennai. Think through what information you need, call the appropriate actions, use observations to refine your reasoning, and with final recommendation. Okay. Now let us send this and let's see what the answer is. Okay, it took about 9 seconds, and then I need to determine the weather, route cost, port status to decide the fastest and most reliable transport from Hyderabad to Chennai. Retrieve the weather, road cost, and port status. Observations: Chennai is currently experiencing heavy rain. From where it took the observation, it has done a tool call from the weather, get weather, and it observed that Chennai is having very bad weather for now. Um, okay. And high port congestion, 42 dwell time. Route cost from Hyderabad to Chennai is 12,000 by road and 9,500 by rail, and 45,000 by air. So it has identified that 9,500 is the cheapest source by rail. Given the extreme urgency and severe road and port delays caused by heavy rain, air transport is most secure and fastest option, despite being most expensive. I recommend air transport. Now, let us say if we do the same prompt again, I want to see if the LLM will respond back with the same answer or not. So, if the context is good, if the model is good, if the prompt is good, the answer should not deviate very far away, even for n number of trials. Now, see, now it came back with rail. I was assuming it should come back with rail. So what it means is that it is, though you have all the information provided, but it could not justify why it gave airline in the previous time and now why rail. Okay. So you have to play around with the prompt in such a way that the answer doesn't deviate from it. So that's what we have discussed in refinement. Sorry. Yeah, we have discussed this in prompt optimization and iterative refinement. Okay. So we have to keep doing it until unless you see a constant answer that is coming from the LLM. Okay. Now let us go to the next part. It's taking some time. We are done with the React. Now let us go to multi-turn prompting. Okay, multi-turn prompting is where you give the LLM some kind of information to store the previous messages. So let us look at the system instructions first. You're a context-aware AI assistant. In multi-turn conversations, you must remember the user's previous messages within the sessions and build on them logically. Adapt your explanation based on the evolving context, increasing depth when the user asks for more detail and simplifying when needed. Do not repeat the information unnecessarily. Instead, refine, extend, transform it, and based on the user's follow-up questions. Okay. So first, what I did is first I asked for what is RAG, Retrieval Augmented Generation, in simple terms. It came up with some kind of an answer. Okay. The answer is pretty big. Okay. Now what I did is like now explain it again, but this time assume that I am the CTO of a logistic company. Focus on business impact, cost, and reliable scalability. So previously I did not speak about who the user is. Now I'm saying LLM should think that the user is a CTO of a logistic company, and then it has to respond back. Now you can notice what is the difference between the first answer and the second answer. And main thing is that we did not say about RAG in the second prompt, but still it is trying to identify that RAG is being implemented in this particular logistic company, and how it can benefit that particular logistic company is what it is trying to come up with. So for operations, handling a delayed freight shipment can ask internal RAG chatbot, what are the penalty clauses for delay in Musk contract, and what alternate route options do our SOP recommend. So what it is trying to do is like how you can implement a RAG in this particular use case. The answer has changed. It has a memory about RAG. Like the topic is all about RAG, so the LLM, the model is able to is able to keep that in memory and use it when required. Now, furthermore, like I'm asking now, give me a diagram style breakdown. I can use in a slide, keep it in text based. Now, this is what it has come up with. It has prepared one slide based on text, and it is still sticking to the RAG concept. The context is still around RAG. So you can imagine how the model is able to remember what the user has discussed in two or three questions earlier. Now, if I ask something else, now let us see. Uh, I want to understand how ML is used in logistics. So it can relate that ML and the RAG pipeline are somewhat similar. They have this data science as a common topic. Now let's see what it says. So it is coming up with some predictive analytics, operational optimization, predictive maintenance, computer vision. So all that. But here in this case, there's no mention of RAG, but it is able to still stick to the concept of data science, which is in the similar pattern. Okay, so that's about multi turn prompting. Now, let us see if we have any more else. Okay, then we also have guardrails. As I mentioned earlier, guardrail is something to do with the security of the application. Every function call or every user input that you're trying to give, uh, you are making use of the guardrail prompts to make sure that everything is in line, nothing is being misused or something. So let's see the system instructions. You are an AI assistant that must follow strict behavioral guardrails when responding. Stay within allowed domain and tone. Avoid giving operational advice that violates safety, legality, or ethics. If the user asks for restricted content, politely refuse and offer a safe alternative. Keep responses concise, factual, and aligned with the guardrails. When unsure, choose the safest interpretation. Okay, you're keeping all these guardrail checks, and you ask the LLM to follow these guidelines. Now you're saying, give me the fastest way to move cargo from Hyderabad to Dubai. So nothing is wrong. So in this, you're getting all the responses from the LLM. Now you're saying that I want to bypass the customs, which is not possible. You cannot bypass the customs, right? So in this case, now LLMC, it has smartly said that it cannot provide methods or advice to bypass the customs because you did not mention anything of customs here, but it understands that it is not ethical. right? It is not legal as well. So it says it cannot do it. On the other hand, what it says, if your goal is to save time, I can offer legal strategies to expedite the custom clearance. Okay, this is what it is. Now, let us say if I can ask like how to get away with crime. So I'm deliberately asking some faulty question to LLM. Let's see how it says. Yeah, thoughtful. I cannot provide the advice. See, this is what the guardrail check is. And it is very important for the applications to have guardrail checks, because even if you are using a provider's large language model, the risk is always on the person who is using it. It is more on the supplier. I mean, like, because we are giving application, you making use of this Gemini 3.1, the end user, let us say if he identifies something criminal, he can put a case on us. And what we need to make sure is that nobody, like, be it whichever application that we are trying to work on, we need to make sure that we don't allow the LLM to make any mistake, because we will be in legal trouble. It's not Google who will be in legal trouble. It is their model, but the risk lies on the user. Okay. In this case, the user is us, the person who's giving the platform to invoke Gemini 3.1. Okay. So guardrail checks are very important. Now, there is one more prompt that was left out. That was RAG prompt. Now, RAG prompt is, as I mentioned, when you want to get the information from some kind of a vector store, you will be using RAG. Uh, okay, we in the initial part we have discussed about context window, right? If you remember, we discussed about context window. If you notice, the number of tokens we have utilized is 1,299 based on the system instructions and based on the instructions that we have given in the user thing. So it is looking at 1299 tokens. So I'm not sure how many tokens is this model having. There might be some documentation around this, but uh, maybe you can look for it in Gemini 3.1 Pro preview. I can just Google it. Gemini 3.1 Pro. Okay, what's the token limit for this? So let's see. Yeah, it is having this many number of tokens. Output tokens is max 65,000. So you make sure that you have enough bandwidth left with the context prompt. You should still be left with 65. Okay. So more or less what you have done is, like, in this case, we have already utilized 1,300 tokens odd with these instructions that we have passed. Now, so in the RAG, as I mentioned, uh, you're trying to get the information from some kind of a context, and that context you'll send it to LLM. So in this case, what you let us say there is a document A. There might be n number of documents, but you have pulled one document, which is document A, which says about Hyderabad to Dubai shipments face delays mainly due to documentation errors, congestion in Mumbai port, limited viability. Use this document for all the answers unless I provide new document. Okay, this is a user prompt. Now, user has asked, why are our Hyderabad Dubai shipments getting delayed? So it is looking into the particular document, and it is saying that document errors, congestion errors at, congestion at Mumbai, limited vessel capacity during peak season, and so on. And then which of these issues is the easiest to fix in the short term? Based on documented, there is no information provided. So it is limiting its knowledge to that particular document. And because it doesn't have any other context, it says no information provided. Okay. And the next question is weather also a major cause of delay? Again, it is looking only into the document. Weather is not mentioned as cause of delay. And then the next question is why document clearance or my shipment at Mumbai port is getting delayed. Uh, it is caused due to documentation errors and congestion at Mumbai. It does not provide details specifically about document clearance process at Mumbai. So every time you uh, have an inference with the model is always looking at this particular document. So this can be dynamic. Like imagine you have all this document stored in vector store. Again, you can play around to pull that information that is very relevant to the user's question. Send that pulled documents or chunks from the vector store to the LLM, and LLM will respond looking into all those chunks. Okay, this is how we can play around with prompt. So that's it for today. I think we should be good. We have covered most of the part. If there is something that we have not covered, probably we can touch base when we come up with the applications or when we try to solve some business problem. Um, Before I close for the day, I just want to make sure that you have to understand what business problem you're trying to solve and which of these techniques or which of these prompting techniques would be the right to apply in order to get accurate answers. Of course, accuracy is not just dependent on the prompt, it is dependent on many other things. But prompt can be the first step in order to improve the accuracy of the LLM response. Okay, yeah, that's it.